I wrote this sheet so that we could fix Friday's lesson. The equation I should have given you is this one that appears right here. And as you can see by my emphasis, it should have been a 7 and not a 1. Since 2x to the fourth is a quartic equation, we can expect to have 4 solutions, and since it's not quadratic, we can't find any of the solutions immediately using the quadratic formula. So the strategy we're practicing today is the one that comes from the rational root theorem, which means listing possible rational roots. Rational roots are numbers that appear in fraction form and that are sort of self-contained and perfect. The way to make a list of possible rational roots is to note the number on the end called the constant, which contributes to the numbers inside the parentheses that appear on the end, and the number in the front, which is the lead coefficient, which contributes to making the numbers in the front of the parentheses. The numbers on the end contribute to the numerator, which is why I made this a blue 2, and the numbers in the front contribute to the denominator, which is why I made this a red 2. Now that I know that I want the factors of blue 2 over the factors of red 2, and I really hate this problem because who puts the same number on the front and on the end? However, the possible rational roots are the numbers made from 1 and 2 in the numerator and 1 and 2 in the denominator. So I made 1 over red 1, which I didn't bother to write, 2 over the red 1, which I didn't bother to write, the blue 1 over the red 2, which gave me 1/2, and the blue 2 over the red 2, which gave me the number 1, which I already had. So there are 1, 2, 3, 4 numbers that I can make, one of them being a double, so it's actually only 3 roots that could possibly be solutions to this equation. Now, in the olden days, before we had any help from anyone, we had to try all 6. Why do I say 6? Because I don't really know for sure whether it's plus or minus. So I would have had to try positive 1, 2.5, and then negative 1, 2.5. And if none of them were roots, and I couldn't do anything to reduce, so to speak, the equation from an x fourth to an x cubed, and then hopefully from an x cubed to an x squared, then the problem could not have been solved by this method. However, I did give you a hint, and that was that x equals 2 really is a root. So we learned how to use synthetic division. X minus 2 is the factor, x equals 2, positive 2 is the number we divide with for the shortcut purposes. We put the coefficients from x fourth to x cubed, here's the x cubed, negative 1, the negative 7, wish I knew that on Friday. The positive 1 came from the number in front of x, even though it's invisible, and the 2 came from the 2 on the end. Then, as you know, we bring down the first number, multiply, record the answer, and add. Then we multiply a second time, record that answer and add, multiply a third time, record that answer and add, and finally we get to the remainder of 0, which I checked off because that confirmed that x equals 2 is a root and x minus 2 is a factor. I showed you over here how you could show that the original equation was now factored into an x minus 2 factor and a cubic factor, but because of the numbers in the cube, we can't factor this either. So I plan to give you a second root for now until we learn how to find the roots ourselves, and the second root happens to be x equals negative 1/2. So again, you have to pick up where you left off. You have to pick up where you left off. Please remember that. After I use x equals 2 and get down to the cubic level, I won't get to the x squared level unless I use x equals negative 1/2 to factor the remaining factor. I want to split this factor into 2 new factors. I don't want to start all over again. When I use x equals negative 1/2, the math becomes interesting, but it always works out nicely. And when I'm all finished, there's my r equals 0 to show that x equals negative 1/2 was a root. The factor was actually 2x minus 1, and we had a whole discussion in class about how to rearrange this piece together with this piece to see it without any fractions. But meanwhile, at this point in time, we're at the x squared level, where have 2x squared plus 2x minus 2 equals 0. So at that point, we simplified by dividing out the 2. It's an equation. We're allowed to do that. I used the quadratic formula, and then I used my calculator to help me, and I ended up with the 2 remaining roots. If on the math test I give you a quartic, I will give you 2 roots. If I only give you a cubic, then I only have to give you 1. Whatever gets you to the x squared level and allows you to use the quadratic formula will be enough to allow you to solve the equation. I hope this little sheet and I hope our little discussion helped you with this information.